Welcome to devlog number 4. In the last devlog, I realized I had no idea how much abstraction I actually need for my combat prototype. I didn't have the experience or the code in my prototype to figure it out. Although I've been coding for like 6 years, I've hardly done any game development before, so instead of designing a really beautiful API and design, I decided to just write a bunch of trash code that gets the job done. Only then can I figure out a better approach, which I'll do at the end of the video. And from the state of my prototype from the previous devlog, I really need to lock in. Unfortunately, this means violating a very important idea from clean code, which is the single responsibility principle. The idea is that when you have a class or a function, it should only do one thing, and it should do that one thing very well. If you want to do a more complicated task, then you simply just have multiple functions or classes which each just do a single thing very well. You compose them all together, and then it works. Yay! Instead, I let nature take its course. I don't impose such artificial constraints on my code. So, essentially what happens is when a mommy class and a daddy class love each other very, very much, they combine together to form one single class which does every single thing. Anyway, remember, I have very little game development experience. I don't really know what I'm doing a lot of the time, but I'm going to build a game anyway, and anything that I learn, I'll explain as I go along. So yeah, let's get started. Firstly, this is a weird turn-based real-time hybrid combat system. Devlog 1 is where I explain it all in detail. Basically, just imagine turn-based combat, but drunk. Okay, so first issue. Currently, all my actions just involve clicking on the action you want, and then it just happens. So, for example, jumping, you just click on jump and then you jump up. Okay, great. But with movement, for example, you want to be able to like click on a point and say, okay, I want to go to there. Or with an explosion, you want to be able to say, okay, I'm going to click here and the explosion is going to happen there. So we need an input stage. The problem is our current camera angle is really, really bad. So we should really switch to a different camera angle, or be able to adjust the camera angle when we receive input. But while we're on the topic of adjusting camera, why don't we make the default view better? The camera should be facing in the same direction as the player, a bit above them, and a bit behind them too. To get the same direction, we just set the camera's basis to the player's basis. But my code didn't work for some reason, and for once I had a really good idea for debugging something like this. So for the intro to my piano video, which was the previous video I just did, I made an animation in Blender where a cat just jumped onto a piano stool and started playing the piano. And in Blender, there's a fly camera feature. Basically, you can use the camera as if you were navigating like a character, and that's very useful to position the camera. This made me realize, why don't I make the camera movable? And this really helped me figure out where the camera was, and I managed to correct my code and it works. Yay. Back to the original problem, getting a good camera angle so I can select a position for my abilities. So I'm just going to use a top-down view here, and that's pretty easy to implement. We can just use the look at method, just to look directly down at the player. So now the player can click on a point on the ground, and that represents a position, and surely we can just use that position as, well, for whatever we need. But how do we convert a point on the screen where the player clicks on to an actual position that we can use? Well, luckily for me, I actually found the correct part of the Godot documentation. There's a collision event which appears when you click on a collidable object. Point is, it gives it a position back, and you can just use that. So that's the input phase for explosion and movement abilities. That was actually really easy. So we've got an okayish set of abilities, so now I can start actually balancing this prototype. Currently, each turn feels too short. Instead of being like slow motion real time, it's more like a stuttering set of frames. So why don't you just make them move longer, Kenny? Well, if I did that, the problem is because the physics is happening too quickly, we lose a lot of the interesting combinations. I want to be able to jump on turn 1, for example, and then on turn 2, while I'm partially falling down from that jump, so still mid-air, I can throw a slipper. The solution was to slow down the timescale of the whole world. Now, that might sound a bit dramatic, but turns out I don't really think there's a better way. You might think that you can just apply a smaller impulse onto the rigid body, but while that does make it slower, it also means that the overall trajectory has a smaller distance overall, and that's no good. I even thought of a genius hack where I inherit from rigid body, and then I override the physics process method, and to the base physics process, I pass in a delta time value which is scaled down, in effect stretching out the trajectory with respect to time. I thought I was so clever, but it doesn't work. We know from previous devlogs that rigid bodies are far above such measly attempts to violate the laws of physics. Slowing down the world, it is. Usually in games, if you want to attack in a different direction or position, you have to rotate or move the whole character. Otherwise, you can only attack straight forwards, like this. However, I'm a special snowflake one. Oh, really, Kenny, really. I instead wanted the player to be able to throw a projectile forwards in any direction they wanted without themselves rotating. What a stupid idea. Well, to be fair, the reason why I wanted to do it was because, you know when you're getting chased by an enemy in a game and you're running away from them, you have to choose, okay, do I continue running away from them to try and escape? Or do I turn around and start attacking the enemy? That's the kind of dilemma I wanted to have in this. I felt that, if you could rotate 180 degrees and throw a slipper all in the same turn, that kind of takes away that tension. Actually, wait a second. I would still have that same tension if I just allowed the player to rotate and attack at the same time, because they're still sacrificing a turn for attacking instead of moving. So I just wasted 2 hours trying to implement my stupid idea. Well, it turns out the conventional way was easier to program anyway. Also, I know I should be using a spring arm or something like that for the camera, but whatever, that's future Kenny's. So here are some smaller other things I worked on. So I added damage numbers. So when you attack an enemy, a number appears which indicates how much damage you did. Also, because of how this combat system works, it's pretty difficult to keep track of what abilities are going on at the same time, so I made a table. Now here's the moment of truth. This is what the prototype looks like. Yeah, I mean, it's pretty ugly, but to be fair, I spent 0 effort trying to make it look good. That's not the point. The point is to try and make something that works, and to be honest, I'm pretty satisfied with what I got. I think it's actually kind of fun. So all of these features I've talked about were made in a very ad hoc way, with very, very little planning. However, now that all the code does exist, I can analyze where the pain points are, and what abstractions I need to do to fix them. I ran into an issue while dealing with the damage numbers. We need to know when we did damage to someone and who we did damage to so we can spawn the damage number in the correct location. The problem is that we don't really have a good place to actually do that in. All of the combat logic is essentially stuffed down the ability and player classes. So I need to start there. In the player class, HP is a property, so I can invoke an event in the setter, and the battle class can just listen to that. But health can change through fall damage, health potions, and leveling up. So we need to rewrite the player class so that it only emits this event when an enemy does damage to it. And while we definitely can handle this okay using traditional object-oriented programming, I realized there might be a better solution. So a while ago, I watched a video by the GOAT, Casey Muratori, and he was giving a talk about how encapsulation was often done really very wrongly. So imagine you're playing a game. So you as a player, what do you see? You see a player, you see the enemies and their abilities. Now, abilities damage enemies, and when you damage an enemy, you see a damage number appearing. So it kind of makes sense that you have an ability class, and that ability class then detects when it hits an enemy, and when the enemy is hit, then it spawns in a damage number. Seems reasonable. But there are so many things which make combat so complicated. Buffs, armor, critical hits, elemental strengths and weaknesses, etc., etc. The issue is that you're spreading the logic across the entities of the battle system. So not only do you have weaker cohesion, since all of the battle logic is spread everywhere around, but because all of these entities, these enemies and players, they need to know about how the battle system works. So you also have worse encapsulation overall, because everyone knows everything. The solution is to take the logic from our entities and put them into a system class. The entities become really dumb objects, mostly just data, and they make calls to the system class. In other words, the entity class code represents the intent, and the system class code represents the implementation of that intent. For our damage numbers example, we have a battle system class which has a do damage method. That do damage method raises an event if damage is actually dealt to a player, and that's the perfect hook that the battle class can use to display a damage number. So the title of this video is a rather bold claim that the ends justify the means, but hopefully I think you should be able to see that the ends, the prototype I made, actually satisfied two types of means here. They justified violating the single responsibility principle, since I was able to get so much more code written than I did last devlog, but they also justify the future means, this move towards a system-based architecture. As an interesting closing thought, I'd say this is actually quite similar to how I'd prove things in a mathematical context. So unless you solved like a similar proof before, you don't just design a proof just like that. You don't say, okay, I'm doing this and this and this and this just like that. Instead, you toy around with the ideas a little bit. You think about what assumptions you're allowed to make and what lines of logic lead on from that. And you keep on trying trial and error until you get what you need. And I would explain that in more detail, but really what I'm trying to say is the Curry-Howard correspondence between proofs and programs. So read that if you're interested. So that's a wrap. I think I'm going to pause videos on the combat prototype because I'm pretty happy with it as it is, and I'll refactor it. That's not really very interesting for you to watch, so I'm going to focus on something else in game development next time. Maybe a dialogue system, something that's actually fun, you know? But yeah, thanks for watching, and like and subscribe, blah blah blah. See you next week. Have a nice day.